Today we're going to be working on 11.4 multiplying and dividing rational expressions. Alright, here are the steps for multiplying and dividing rational expressions. First, you are going to factor all the numerators and all the denominators completely. The big idea here is you're going to need to factor to simplify. You're going to simplify by cross dividing. This is something you have done in the past, and I'm just going to review that with you. You'll multiply like you would normally multiply a fraction. Numerators times numerators and denominators times denominators. Then of course you're going to state the excluded values on the variable. So let's take a look at number 1. 14/15 times 5/21. Now this problem has no variables in it, and I'm using it to explain what you've done in the past. What you've been taught is when you have fractions like this that you can look diagonally and see if these fractions can be simplified before you multiply. So if we look here at this diagonal, 5 and 15 have a common factor of 5. So I'm going to divide them both by 5. The other diagonal here has a common factor of 7. So I'm going to divide them both by 7. And what you've done is by cross division, you were able to simplify the fraction and make the problem easier to do. 2 times 1 is 2. 3 times 3 is 9. And that's the answer to this problem, 2/9. Can you simplify before you multiply? That's incredibly important when we do ones that have variables in it. For example 2, these are monomials and they have variables in it. The concept is exactly the same. So I have y to the third and y squared. When I look at this diagonal, they have a common factor of y squared. Y squared will divide into both of them. So I'm going to go ahead and do that. Y squared divided by y squared is 1. Y to the third divided by y squared is y to the first. On my other diagonal, 6x and 15, 3 goes into both of those. 6x divided by 3 is 2x. 15 divided by 3 is 5. And now we've simplified this, we can now multiply. Numerator times numerator will give me 2x. Denominator times denominator will give me 5y. And that's the answer. I do need excluded values anytime there's variables in my denominator. And in this one, I have a y in my denominator, but when it's a monomial, y cannot equal 0. In this one, it's a number, so there is no excluded value. And then x does not appear in the denominator, so I do not need excluded values for x. Number 3. Again, I have monomials. So when I have monomials, I just can divide them. So I have a monomial here of v and v to the third. V is a common factor, so I'll divide them both by v. Here, I have a common factor of 2w, so I'll multiply that or divide that by 2w, and I'm going to get 2 here. And I'm going to get w here. And now I can multiply. 2 times v squared is 2v squared. 1 times w is w. And that's the answer. Excluded values for the first fraction. I have a v and it's a monomial, so v cannot equal 0. For my other ones, again, it's a monomial, but the variable is w, so w also cannot equal 0. And that is the answer. And that's what you do when you have all monomials. Looking at number 4, we have 3 monomials and a binomial. The rules for monomials and polynomials are different, and it's really important not to do the same thing for them. They're completely different. So let me show you how this works. In my first diagonal, they're monomials. So I'm going to do them like I normally would. I'm going to look for that common factor. So 2x to the third and 4x to the third have a common factor of 2x to the third. So I'm going to divide this one by 2x to the third, and I'm going to get 1. Divide this one by 2x to the third, and I'm going to get 2. Monomials and binomials cannot be simplified. They have to either be both monomials or both polynomials. So I can't do anything here with this one, so I'm just going to multiply. 5 times 2 is 10. 1 times x plus 1, whenever you're multiplying a number or a monomial times a binomial, you do have to distribute. That makes that x plus 1. And that's the answer. Excluded values. X cannot equal. For the first one, again, it's a monomial, so that'd be 0. For the second one, what number would make this 0? Well, that would be -1, and that's our other excluded value. The correct answer to this one is 10 over x plus 1. Let me show it to you one more time. Again, for this first diagonal, I have a monomial and a binomial. I cannot simplify that. For this one, I have a monomial and a monomial. I can simplify that, and 4n is a common factor, so I'll divide them by 4n. And then I'm going to multiply. 2n times 3 is 6n. And I have to distribute. 1 times n minus 5 is n minus 5. And this will be the answer. Excluded values, 5 and 0. All right, number 6, getting a little harder. Again, I'm going to use the same concept. I am going to look diagonally to see if I have any common factors that I can simplify. So my first diagonal here, I have monomials. So I'm going to look for the common factor of the monomials, and it's c. So this will be 3, and this will be c. Look diagonally at this one, I have a binomial and a binomial. If you have polynomials that line up diagonally, you can simplify them. You just have to factor them first. So c plus 2 is prime. It's already factored, but I'm going to put it in parentheses because they are a binomial, so they're together. C squared minus 4 is a difference of 2 squares, so I'm going to get c plus 2. And c minus 2. And now if I look closely at my diagonal, I have a common factor of c plus 2. So I can divide them both by c plus 2. For this one, I'm left with 1, and for this one, I'm left with c minus 2. Now I can multiply. 1 times 3 is 3. C times c minus 2, again, I'm going to distribute. It's going to be c squared minus 2c. And that's the answer. I need to state my excluded values. Monomial with a variable, so that's 0. For this one, I do have to look at ones even though I've crossed them off. So for this binomial here, I would get -2 as an excluded value. And for this one here, it would be +2 as an excluded value. Again, one of the other things that's nice about factoring is you would have had to factor it anyway to get the excluded value. So you're basically killing 2 birds with 1 stone. All right, let's take a look at 7. Again, diagonals. Monomial, monomial. That's good news. I can simplify. 3 is a common factor. Polynomial, polynomial. Doesn't matter that it's a binomial and a trinomial. As long as they have pluses and minuses in it, they can be simplified with each other. So I'm going to factor the top one with the GCF. That'll be 2 parentheses z minus 2. And down here, I have a trinomial that I would use product sum. This will be z minus 5 and z minus 2. You need to know a lot of factoring to do this chapter, so if you need to go back to chapter 7 to review factoring, please do that. Alright, and now you see that when we did that, we ended up with a common factor, so we can cross them off. And our correct answer here is 2 times or 2 times 1, which is 2, over 2 times z minus 5 is 2z minus 10. Excluded values, z cannot equal, no variable, so nothing, positive 5, positive 2. Go ahead and pause the video and try number 8. Okay, hopefully you saw we had a monomial and a monomial, and h was the common factor. And here you had a binomial and a trinomial. They're a polynomial, so you have to factor them. This one was prime, and this one factored into h plus 3, h plus 2, which gave us a common factor to cross off. And you ended up with an answer of h plus 3 over h. Before we go on to the last one, I want to show you or talk about the most common mistake that happens in these problems is we'll get a little overexcited and we'll see these h's here and want to, with everything in our bones, to cross off these h's. But we can't, because this is a binomial and this is a monomial, and you can't simplify a polynomial and a monomial together. They have separate rules. So resist everything in your bones to cross off those h's. If you do, you will pretty much get every problem wrong on your assignment today. All right, number 9, last one I want to do, has one fraction and the other one is not a fraction. And I just want to remind you that the same principles you learned about fractions earlier in your math careers is the same applies now, that you should put this over 1. So you make 2 fractions. And you do exactly the same thing that we've been doing. So monomial and monomial, look at it, no common factors. Binomial, binomial, look at them. We have to factor to see if there are common factors. So in my top one here, the common factor is b. Well, not the common factor, sorry, the GCF is b. And we get 4b minus 3 times b. Down here, the common factor is 10b squared. And we're left with 4b minus 3. And good thing we did it, because I see a common factor, 4b minus 3, so I'm going to go ahead and simplify that. And most people here would think that that's done, but I want to show you one more thing. Occasionally, you will get a fraction that has not been simplified before putting in the problem. If you'll notice, I have this 5b squared, and down here I have this monomial 10b squared. If you can simplify the numerator and the denominator of the same fraction, you can do that as well. That's what we learned yesterday in 11.3. So 5b squared is a common factor. This, again, I can do this because this is now a monomial and this is a monomial, so that's a legal move. And if I divide that by 5b squared, I get 1. And divide this by 10b squared, I'm going to get 2. Now I can multiply. b times 1 is b. 1 times 2 is 2. The answer here is b over 2. Excluded values, monomial, no variable, no excluded value. Here, when I factor this, I got a monomial with a variable, so b cannot be equal to 0. And for the other one, 4b minus 3, we're going to have to solve that one. Add 3. 4b equals 3, or cannot equal 3. Divide by 4. b cannot equal 3/4. My other excluded value is 3/4. Again, this is a lot of factoring, so if you have trouble with factoring, please go back and review Chapter 7 and refresh it so that you are good to go. All right, that's it for today. We're only going to do the first page. Tomorrow we will do dividing rational expressions. I hope you all have a great day.